Hi, welcome to Systems of Equations tutorial number 4. So in the last tutorial, we did some basic elimination. We either added or subtracted to cancel out one of our variables. And so today's lesson is going to be a little bit more difficult. And so I'll show you what I mean. Let's look at example number 1. If we were to add or subtract this system of equations that we're given, it's like, ooh, nothing's going to cancel out. So once again, we still have the same steps that we were doing before, but we're going to add some new steps to it. We still have step 1. We need both equations to be in standard form. So that's true. Step 1's good to go. Step 2 says, hey, see if you can add or subtract it, the two equations, and have something be eliminated, right? Either the x or the y's. Well, we look at these two equations as like, that's not going to happen. So now we need a new step. And that's today's lesson. Step 3, it looks kind of weird. Make a wish, then make it come true. But that's the best way I could explain the step 3. So here's the deal. I look at this second equation like, oh, I wish instead of y, I wish that were a 5y, right? If someone could just come in and make that be a 5y, then my y's would cancel out, and I'd be done with this problem, and I could move on. Well, we made our wish. We wish that y is really a 5y, and now we're going to make it come true. Now, I just can't do what I did just then. I can't go ahead and just put a 5 in front of the y, because then that means I changed the whole equation. But what I can do is if I make a change to one term, as long as I make that same change to every other term in that equation, I am okay. I'm not breaking any laws. So if I want to make a y into a 5y, I say, well, how do I do that? Well, I multiply that y times 5. So as long as every term in this equation gets multiplied by 5, then I'm good to go. I'm just rewriting the equation, and I'm making it look a little different, but it's still the same equation deep down underneath. So 5 times 3x is 15x, 5 times y is 5y, and 5 times 10 is 50. Now, before we move on, I want you to really buy into this. Look at the new equation that I just wrote, and now imagine that you were going to simplify this equation. You were going to divide every single term by 5. We would get right back to the equation that we started with, right? That's why it's still the same equation. It looks different, but it's really the same equation. But the nice thing about changing it, making a wish and then making the wish come true, is that now when I line up these two equations, I'm like, oh, I already know how to do this, and I'm good to go. There's nothing new here. Let's just finish it just because. Let's go ahead and the y's cancel out, and then we're going to divide both sides by 19. And does 19 go in 57 3 times? That sounds good. I believe that's true. Let's go ahead and have a calculator, but sounds good. Let's go ahead and plug 3 in for x. So we get 4 times 3 minus 5y equals 7. Let's solve for y, because we know when we solve a system of equations, our answer is a coordinate point. It's a two-step, obviously, so we've got negative 5y equals negative 5. Divide both sides by negative 5. I get y equals 1. Put it all together. My answer appears to be 3, 1. I always like to stop and plug it into at least one of the equations and make sure that it's right. If I plug in 3 to the original one, I get 12. 12 minus 5 is 7. That's good. So there you go. We made a wish, and we made it come true, and we learned a new step. So here, example number 2, I see that when I'm looking at step 1, I'm like, uh-oh, I've seen this before, right? In our last video, in our practice, we've done this. But our second equation's good to go. Our first equation needs to be rewritten, right? We need to have it in standard form. So we're going to go ahead and subtract the 5x from both sides. I could write this as 7y minus 5x, but that wouldn't be in standard form. Standard form has to have the x term first. So I'm going to rewrite it as negative 5x plus 7y. Sometimes people say, why are you writing plus 7y? Well, 7y is positive, right? So I have to put something to the left of it to separate it from the negative 5x. So if 7's positive, that's why I put a plus there. And now I'm going to bring down the second equation. And I am done with step 1. So step 2 is, hey, can anything cancel out just on its own by adding or subtracting? No. So we can't do step 2. We've got to move to step 3, make a wish, and make your wish come true. So what do we wish? Well, I'm never going to be able to make an 8 into a 5 or a 5 into an 8. But when I look at the y terms, see how it would be so nice. Oh, I just wish that 7y were a negative 14y. If 7y were a negative 14y, then I could go ahead and have my y's cancel out. How am I going to make a 7y be a negative 14y? That's right, I'm going to multiply it by negative 2. So if I multiply that by negative 2, I'm multiplying everything by negative 2. So let's bring this down. Negative 5x times negative 2 is 10x. 7y times negative 2 is negative 14y. And 12 times negative 2 is negative 24. Bring down this. And it'd be, what, 8x plus 14y equals 6. And now we're really back to the previous lesson. We know how to do this. I'm going to go ahead and quickly do it. But the lesson here is, hey, we had to rearrange to get in standard form. Then we had to make a wish and make it come true. And now we're just simply adding the two equations together. This is a method called elimination that allows us to just solve systems pretty quickly. I kind of like this method. I don't know about you, but okay, x equals negative 1. Let's take negative 1 and plug it into either equation. I'll go ahead this time just to change things around. I'm going to plug it into the second equation, bring that down. So let's see, we have 8, and then instead of x, I'll put a negative 1. And then what else do we have? Plus 14y. Ooh, I'm running out of space, equals 6. So I'll get negative 8 plus 14y equals 6. It's 2 steps. I'm going to add 8 to both sides. I'll get 14y equals 14. Woo! Really running out of space. Y equals 1. Put it all together. That means that we'll have our answer of negative 1, 1. I always like to double check. You know me. I like to check my answer before I move on. If I plug it into the second equation, negative 8 plus 14 does give me 6. So that is correct. All right, halfway done with the lesson. All right, so here, they're all in standard form. So step 1, we don't have to do. Step 2, darn it, nothing's going to cancel out on its own, so we can't do step 2. Step 3, make a wish and make it come true. Uh-oh. Uh-oh. All right, I'm seeing some trouble here because I cannot make a 5 into a negative 4 by multiplying by anything, right? I can't make a 2 into a negative 3. Oh, no, step 3 is not going to work. All right, thank goodness there's a step 4, and that is make a wish twice. So here's how it works. I'm going to focus on, let's get my, let's see, I'm going to focus on the y terms, okay? And the reason why I'm going to focus on the y terms is that let me see if I have my, no, if I don't have my thing back. All right, so the reason why I'm going to focus on the y terms, let me get my pens back. Okay, so I'm going to focus on the y terms because I'm like, ooh, 2, negative 3. I think I can go ahead and change those, right? I can go ahead and make the 2y into a 6y, right? Make into a 6y, and I can make the negative 3y into a negative 6y, and then they would cancel out. So the nice thing about this is that, whoa, I don't know what my smart notebook's doing right now. It's kind of like taking over, isn't it? I must have clicked something that it's not. I just want a regular pen. There we go. All right. And so what we're going to do is we're going to make a wish twice. To make that happen, we're going to say, okay, to make that 2y into a 6y, I'm going to have to multiply everything by 3. So I'm going to change this first equation. 5x times 3 is 15x. 2y times 3 is 6y. And 16 times 3 is 48. And then I'm going to change this next one. I'm going to multiply everything by 2, right? Because if I do that, I get negative 8x, and then I get 2 times negative 3y is negative 6y, and 17 times negative 2 is negative 34. All right, let's stop for a second because the rest is history, right? We know how to do the rest. Sometimes You can't just make a wish once. You got to change both of them so that they cancel out. And so this is what we're doing this time. We made the 2y and the negative 3y, we made them both change so that one could be a 6y and one could be a negative 6y. And now the rest is pretty basic, right? We're just going to add 15x plus negative 8x, or 15x minus 8x is going to give me a 7x. My 6y and negative 6y cancel out. I don't write anything there. 48 minus 34, let's see, that gives me a 14, right? Divide both sides by 7, and I get x equals 2. I'm going to take that 2, plug it into the original equation, switch up colors, so I get 5 times 2 plus 2y equals 16. It's just a two-step, right? I'm going to go ahead and subtract 10 from both sides. 2y equals 6, and y equals 3. Let's put them all together, and we get the answer of 2 comma 3. If I plug that into my first equation, I'm going to get 10 plus 6. Yep, that's 16. That's correct. All right, so let's see if we can do that again. Actually, this time, we're not going to need to do it again. So the only time you're ever going to have to make a wish twice is if making a wish once doesn't work. So you have to change, you have to pick the same variable to focus on, and you change both of them so that they cancel out. And that's what we did in that step. This step's going to offer something new, but we're just going to make a wish once. Okay, step 1, yep, they're all in standard form, so we're good. Step 2, nope, we're going to need to make a wish. Nothing's going to cancel out on its own. What do you guys wish for? Yeah, I wish that this negative 2y were a negative 6y. So I'm going to multiply everything by 3, everything in this equation by 3. So let's see, that gives me negative 9x minus 6y equals 90. And then I'm going to go ahead and bring that first equation back up. I'm going to add, oh my goodness, I see what you're talking about, right? Crazy. If we add these two, look what happens. 9x minus 9x, gone. When you say gone, you don't write anything. 6y minus 6y, gone. Oh no. All right, I just said don't write anything. But when there's nothing on one side of the equal sign, what do you have to write? That's right, you have to write 0. You can't just leave it blank if there's nothing there. And then negative 18 plus 90, that's going to give me what? 72. Uh-oh, that's crazy, right? 72. Does 0 equal 72? So we're in this example where all of a sudden our x's fell away, and we just have a statement, 0 equals 72. Does 0 equal 72? No. So that means that our answer is no solution. That means no matter what numbers you think of, there's not an x and a y that you could plug in and make both of these statements true. You could find something that would make each one of them true, but there's nothing out there, there's no point, there's no xy coordinate point that would make both of these be true. And we know if we graph them, then that means that they would not intersect. All right. Once again, when you're learning something new, practice, practice, practice is so important. Thanks for joining me, and have fun practicing.